Hello, Chem 110. This video is a short introduction to significant figures, or Sig Figs. And this introduction specifically is going to just go over how to identify the number of Sig Figs in a given number and how to round a number to the requested number of Sig Figs. So I want to start actually just by talking a little bit briefly about the meaning, because I think this actually helps you figure out Sig Figs. So here's how I like to think of the meaning of sig figs. And that is if I have something that I measure as 25 milliliters, can write it like that. And depending on how I measure it, I might write it like that. And these two numbers have two very different meanings. So absent any other information, like I haven't told you something about error bars, if you read this number 25 milliliters and you look at what we call the last sig fig, so the digit that is significant that it is in the smallest place or the most precise place, this means plus or minus one in that place. So if I tell you something is 25 milliliters with written just like that, what I'm really telling you is that I know for sure it's somewhere between 24 and 26 milliliters because I can be plus or minus one where the 5 is. On the other hand, if I tell you something is 25.0 milliliters, that means that I'm plus or minus one in the last digit here, and we'll talk about how you know that's significant in a minute, but it is. And so that means this is somewhere between 24.9 and 25.1 milliliters. So these are two pretty different measurements, right? This is much more approximate. This is much more precise. And significant figures are really all about measurement. And then we take measurements and we put them in calculations. So when we do calculations in chemistry, we really need to practice pretending that they're coming from real measurements so that we can handle real measurements correctly when we do them. All right, so that's the meaning. Now I'm going to tell you how I knew where the significant figures in these numbers were. So I have some examples over here on the right. We're going to identify the number of sig figs in these numbers. And right here, I have cut and paste from your book the guidelines for using significant figures. And these are long and they look confusing. So I think to me, the easiest way to go through these is to look at examples that are illustrated by these 5 points. So if we look at our first number here, 31, and then I look at the first rule, it says any digit that is not 0 is significant. So both these numbers are significant, they're not 0. And so I'm done. So this has 2 sig figs. All right, I go to the next one. Well, I already know that these are both going to be significant because they're non-zero. And if I look at rule 2, it says zeros between non-zero digits are significant. This 0 is between two non-zero digits, so it is also significant. So this one has 3 sig figs. All right, so now going to the third example, again, I can see the 3 and the 1 will be significant. So what about these 4 zeros? Well, they conveniently, because I wrote it this way, relate to 0.3. Zeros to the left of the first non-zero digit are not significant. So these numbers here are not significant. They have to be there. They're just placeholders. All right, so this number also, just like the first one, has 2 sig figs. All right, so we've gotten through the first 3 rules. Let's look at our next number here. So 31,000, these two are significant. All right, so this actually, I went out of order here just to mix things up. This result corresponds to the 5th one here. For numbers that do not contain decimal points, that's this one. There's no decimal point in this number. And this says, unfortunately, the trailing zeros, the zeros after the last non-zero digit, may or may not be significant. All right, so this one is an example of something that is kind of ambiguous. And I'm going to show you in a minute how to avoid that. These are ambiguous. They have to be there, right, to make it 31,000. So it could be that I mean this to be my last significant figure, and it's somewhere between 30,000 and 32,000. Or I could mean that these are all significant and it's somewhere between 30,999 and 31,001. I can't tell. So this somewhat unsatisfying answer here is that this is either equal to 2 sig figs, or could be that all 5, or actually it could be that 3 or 4, like we really don't know. So I would advise you in this class to assume, unless told otherwise, that it's the lowest number of sig figs. And I'm going to make a little asterisk here because I don't have space here and say there's a way to avoid this ambiguity, and that is as follows. So here's an unambiguous way to write this, which would be in scientific notation. So if I write 3.1 times 10 to the, and I'm going to show you how I figured that out, 3.1 times 10 to the 1, 2, 3, 4 times 10 to the 4, that number has 2 sig figs. When you look at scientific notation, then you look at the sig figs in this number, and the exponent is actually irrelevant. This has no bearing on your sig figs. All right. If I write this number as 3.100, for instance, times 10 to the 4th, it's still the same number. It's still 31,000. But now this number here has these two numbers are significant. And these next two numbers are also significant because of this rule here. If a number is greater than 1, all the zeros written to the right of the decimal point count as significant figures. So these zeros are to the right of the decimal point, and this number, 3.1, is greater than 1. So those are all significant. So this one here, if I wrote it this way, this would be 4 sig figs. So these are two ways to express different sig figs for this number 31,000, which is by itself kind of ambiguous. Anyway, so I wouldn't worry a lot about the ambiguous ones. We'll run into those some, and I'll call them out where they are. But I will accept any answer basically for those. All right, moving on to the next one, 0.0003100. All right, well, we know these are significant because they are non-zero. And then we have two sets of zeros. The ones to the left go back to 0.3. These are zeros to the left of the first non-zero digit, so those are not significant. Okay, and zeros to the right, I'm actually having a moment here. If a number is greater than 1, if a number is less than 1, it's part of number 4, that's this one. This number is less than 1, then only the zeros that are at the end of the number and the zeros between non-zero digits are significant. So these two are significant. So this one has 4 sig figs. The final one, significant, significant. This is a number greater than 1, so all the zeros to the right are significant. This one has 3 sig figs. All right, so that's examples of how to use these rules. And if you aren't used to this or you have some questions, you could take this little page of your book, or you can take the notes from this and just have these with you as you work. All right, so now I'm going to give you, oh, one more thing. Yes, we need to talk about rounding, sorry. Hold on. So the other thing we need to be able to do, you can identify how many sig figs are in a number, but we also need to be able to take a number that we calculated and round it to the correct number of sig figs. So I gave you an example of round 6.048 to 2 sig figs. So the first thing to do is to see that if I have 2 sig figs, I'm going to need a significant figure here and here. So I go to my smallest significant place, the one farthest to the right, and I have to round to that place. To round, I'm going to write this here, I round from the digit to the right, and only one digit to the right. So I look here, and I see that is a 4, and if that's a 4, I'm going to round down, so the answer is 6 0.0. And I did this example specifically because what you do not do is look beyond the 4 at the 8. Sad face, don't look at the 8. Because if you rounded twice, if you rounded to 5, then you might think, oh, now I have to round up, which is actually a separate question we can talk about. But you only look at the digit right next to the one you have to round to. All right, so now you're ready for the practice problems. And I encourage you at this point, if you're watching the video, to stop the video and try these problems on your own. Identify how many sig figs are in these 5 numbers and then round these 2 problems here. And then when you're ready, come back and see my answer. Okay, so 200. This is definitely significant. These are ambiguous. So I would say this is 1 sig fig, but it's also okay to say 2 or 3 if you thought one or both of those zeros might be significant. It's a bad way to write that number. Actually, over to the right, here's a good way to write that number. 2.0 times 10 to the 2, this equals 200, but I've given you more information. This is significant, and then this number to the right of the decimal point, because this is a number greater than 1, is also significant. So this is a way, if I wanted to express 200 with 2 sig figs, that's the way to do it. All right, back to this one, 202. Significant, significant, 0 between non-zero is also significant, so that's 3 sig figs. This number down here, significant, these are not significant because they're to the left. And this one that's all the way to the right for a number less than 1 is significant. So this is also 2 sig figs. And then finally, this one over here, this is 2000. You don't have to write this, I'm just pointing it out to you. But we've made it unambiguous because this is significant and then all the trailing zeros are significant. So this one has 3 sig figs. All right, and now finally rounding. 113.6 to 3 sig figs. I'm going to want this, this, and this to be significant. So this is the place I look to round. It is greater than 5. And so my answer here is I'm going to round, and I round up because it's a 6. So this number becomes 114. Now over here, I've asked you to round the same number to 2 sig figs. So now I'm only going to want to be left with significant digits there. So I look to this number, which is a 3, and that tells me to round down. So my answer is 110. So I get 2 different numbers when I round to different sig figs.